Welcome to everyone to our general membership meeting. Thank you for attending. For those of you who are new to our group, haven't attended before, we typically hold our general membership meeting on the third Tuesday of every month, except for July and August. And unless we decide to change it, it starts at 7:30 on Tuesday, third Tuesday of every month, like I said, except July and August. And the Sierra Club's mission statement, as is ours, is to explore, enjoy, and protect the wild places of the earth. And we also want to protect and restore the environment. And with these meetings, we hope to help educate people, uh, and we hope that they will help us fulfill that mission, that they will also be motivated and come to love the environment, the great outdoors, and help protect the environment that we as humanity also depend on. Do have some announcements. We have a brand new newsletter. It's called the Susquehanna Sierran, uh, and was published for March on our website, which you can find by searching for Susquehanna Group Sierra Club on the internet. And thank you to our excellent editor, Jim Taft, who puts these newsletters together, and also to our writers. Uh, One of the important stories in the current newsletter is a grid scale energy storage project that was proposed by a company called GlidePath for the town of Union, which is very substantial and very important project that could provide up to 4 hours of electrical power for as many as 100,000 households, which is basically more than the population of Broome County. The project would assist the transition to renewable energy, including especially wind and solar, which are intermittent and variable. Another local project, which is not in the newsletter but also is important to help save a habitable climate, is a 20 megawatt solar farm that's proposed by a company called Sun East to be built south of Owego. Uh, I encourage anybody that's interested in this to please learn more. And you can go to the newsletter to see the energy storage project information. There's links there. And also, you can search for the Sun East project for the Owego project. And then I encourage people to support these projects by contacting their elected officials as you see fit. Um, then there's upcoming talks we have scheduled April 20th next month. There's a talk by Christopher Audette, who is the executive director of Waterman Conservation Center. He's going to discuss the Peace Corps experiences that he had in sub-Saharan Africa. And then in May, Roy Hopke, who is a consulting forester, is going to speak on how our forests are transitioning during climate change. Um, Scott has something to talk about too, in terms of an announcement. He's looking for possible help from people to volunteer. Go ahead, Scott.
Yes, I sent out this or plea for help back on late February to the listserv. We are assisting in a project that has been run by a university student, Christine Fuller, and she's been collecting items that students are throwing out at the end of the semester. And her thought was to keep the items out of the landfill and find homes for them or organizations that will take and be able to make use of them. So she's done this for a couple years, but last year they didn't do it because of COVID. And we're looking for people that can assist in the effort, mainly if you have a truck or van right now that can help. We do have storage space. I think we probably have enough. We have a couple people that have garage space, and we just need to be able to collect things there and sort them out in the garage. So, or if you have any interest of any kind, I mean, let me know. You can do that in the chat. And also everybody, feel free to use the chat. And I will, get in touch with you. It, we don't have an exact end date on this, but it's basically the last part of May. The campus is, where the school is closing somewhere around the 26th, or that's when the end of the semester is. So by that point, we expect most of the students to have moved out. So I don't know. I think that's all I have.
Thanks, Scott. I don't have anything to add to that. I don't know any more details, but one thing I wanted to mention too is people that haven't already given us an email address for yourselves, please do so. You can put it into the chat. Um, Hopefully, that will help us in the future when we have things that we can send to you that aren't so easy to do in any other way. We're trying to minimize the need for sending physical mail, and we're working towards trying to eliminate the printed version of our newsletter that has been necessary at least once a year in the past. So that would be helpful to us if you could provide your email. All right, I'm going to go ahead now and introduce David Nicosia. He's a National Weather Service meteorologist. He's going to be discussing bird migration, weather patterns, vagrancy, possible effects of climate change, and renewable energy on bird populations. Uh, Dave grew up in Athens, Pennsylvania, and has had a lifelong interest in weather and climate. He is the warning coordination meteorologist at the National Weather Service in Binghamton. He received both his Bachelor of Science and Master of Science in Meteorology from Penn State. He started with the National Weather Service in 1991 in Michigan. He spent 3 years there before taking a forecaster position at the National Weather Service in State College, Pennsylvania. Then in August 1999, he took his position at the National Weather Service in Binghamton as warning coordination meteorologist, where he remains today. Dave has a wealth of operational forecast experience, which includes the blizzard of 1996, the January 1996 flood, the major floods of 2004, 2005, and the record floods of 2006 and 2011, and the Northeast Pennsylvania tornado outbreak of June 2018. And you can add to the list now the big storm we had December 17th. But anyway, he's provided key briefings for public safety officials that saved many lives during these record floods. For his work during the flood of 2006, Dave was awarded the Susquehanna River Basin Commission's prestigious Maurice K. Goddard Award. He has also got a keen interest in climate and climate change, and in 2008, Dave completed a graduate level course in climatology from SUNY Cortland. In May of 2010, Dave provided a training seminar for the National Weather Service Eastern Region on climate change. He is an avid birder and is recognized as an expert on identifying birds, and every chance he gets, if you're a birder, you may run into him. All right, thank you, Dave, again for agreeing to give this talk, and it's all yours now. Thank you.
All right. Well, again, like I said, thank you for having me. It's just an honor to speak to this group. Really appreciate everything you folks do. I mean, if we didn't have somebody looking after the environment and all the, all the perils that our environment faces, I don't think we'd have the birds that we have today. All the conservation work, environmental work that's been done through the years is really a large part of the reason why we have a lot of the birds that we have today. So, just a great mission what you folks do. So, and again, like I get to talk about both weather and birds, but I think we're going to talk a little more about birds because I don't know, spring is coming, I'm excited. So, and I am interested in climate change as well. And we'll talk a little bit about that and its impact on birds. And then I want to talk about green energy too. There could be some real good opportunities with green energy for our bird populations. So we'll talk a little bit about that too as well. And, you know, towards the end, I'm going to talk about some of this green energy stuff, and I may have some questions for you folks too as well, because it's something that is really starting to make a, you know, it's starting to really like, it's impacting this area with the Windsor project, the wind turbines, and then the Owego solar farms and stuff. So we're starting to see this. So I'd like to get some, it'd be interesting to hear what some of you folks have to say about that as well. So we'll get to that. So I already went through my bio, so I won't repeat it, except I've been actively birding since I was about 11 years old. So I've been at it over 40 years, hard to believe. And I'm still enjoying it. So we're going to talk, first of all, about weather and bird migration, which is something that, you know, weather is a big factor in our, you know, how our birds move. So just starting off with some really basic weather, I'm sure many of you are familiar. You know, there's highs and low pressure systems, variations in atmospheric pressure. The low pressure systems are our storms. The high pressure systems are our fair weather air, you know, our air masses. So air isobars are lines of equal pressure. That's what these green lines are. So the air goes counterclockwise around low pressure and goes clockwise around high pressure. So for instance, in this example here, you've got low pressure coming into the Great Plains. Ahead of it, it's counterclockwise, so you're going to get a south wind ahead of it. On the back side of it, you're going to get a north wind. And these wind directions have a lot to do with migration depending on the season, and we'll talk about that in a little bit. The air is also rising in low pressure systems. As I said, the air moves counterclockwise and it's rising. And when air rises, it cools, condenses into clouds. The clouds get thick enough, we get precipitation. So stormy weather like what we had today, we had a little bit of snow and a little bit of rain mixed in. We had a little bit, a weak low pressure system pass through. The stronger low pressure systems that come through, like the one in December that was mentioned, those can bring heavy precipitation. And then we also have high pressure, which is our fair weather system. So this weekend, I'm very hopeful, looks like we're going to have a very nice high pressure system sit over us. Now, it's not going to be a subtropical high. It's going to be a polar high. But this time of year, all we need is the sun, because the sun angles are getting higher and higher as we approach the vernal equinox. So hopefully we'll have a nice weekend. That would be cool. So high pressure is your air masses and sinking air, okay? And clockwise flow. This is we're just going to stick with the northern hemisphere here, okay? If we go to the southern hemisphere, everything's backwards, but we don't need to talk about that. So cold fronts, leading edge of advancing cold air mass. So the cold air comes in and it lifts the warm air up, and you get clouds and you get precipitation. And ahead of cold fronts, you often have south winds. The cold front hits, the winds turn to the north or northwest generally. And I like to talk about this a little bit because we just had a phenomena. It was, I'm probably going to forget the date. It was a few days back where we had south winds in the morning, and it was very mild. And I don't know if many of you, I know a lot of us birders, the geese were just everywhere. It was amazing. The geese were moving. Then a cold front came through and it was very shallow. And what happened is the winds turned to the north. So all these geese that were really high up were now encountering north winds, and they were starting to drop. So it seems like when you get these air mass changes like this, especially in the spring, you get a cold front, you got birds heading north ahead of the cold front hits, the birds come down, especially if it rains. And in the case on the week, I think it was, I want to say it was Sunday or Monday. Maybe it was Monday. I mean, no, it was last week. It was last week. I lose track of days. But it was awesome because at first the geese were a lot higher, and we had snow and Canada geese. and then the winds turn to the north, and you can feel the chill. And I mean, I had geese probably just a few hundred feet above the ground. It was incredible. So, and then the raptors also came down, which was really neat. So I had a black vulture pass pretty close. It was fairly high up, but it was close enough to see. So it was cool. And it was this front that was bringing everything down. Warm fronts also can bring changes too as well. In fact, that's what we had today. We had a warm front attached to a low pressure system. You get some light snow or precipitation like we had, and then it gets replaced by warmer air. And tomorrow is going to certainly be a much nicer day than today. And the winds are going to be southerly, so we're probably going to see some migration overnight because the winds are going to be more southerly. Whereas today, this morning, it was pretty chilly, right? And this warm front passes through. We had some light snow and mixed precipitation, and it's still drizzling out there now. But tomorrow looks like it'll be a pretty nice day. It's not going to be like 60, but certainly warmer than it has been the last few days. So that's for warm fronts. And again, I got to talk about spring migration. It's my favorite time of the year. So what this is a radar map of the entire country. And this is from a while ago, but it still shows what I want to show. This is showing birds moving. And what I'll point out is the precipitation there's a low pressure area. You can see the counterclockwise flow in the plains. And then you can see the warm front. You see the precipitation north of New York State. But look at all these rings that form. See that? Those are all birds moving north. Remember, low pressure, counterclockwise flow, south winds across almost the eastern, pretty much east of almost the eastern half of the country, not quite. But what's happening here is the sun is setting. And once the sun sets, the birds take off. So these are mostly passerines, our songbirds that migrate at night. So you'll often see these we call radar blooms, or I call them bird blooms that develop at night. And there's massive nocturnal migration going on. And then once the sun rises, the birds drop. So this is an example of nocturnal migration. And if we look at, this is a classic spring signature. You get a low pressure system moving through the upper plains, big Bermuda high pressure off the East Coast, and you get air coming off the Gulf of Mexico north. And it turns out we've all heard about the jet stream, right? Generally it's at high levels of the atmosphere. It's called jet stream because there's rivers of very strong winds 30,000 feet up where the jets fly, right? It also turns out there are jet streams that form in the lower atmosphere. And in the springtime, with this type of pattern, which becomes common in the springtime, because as the sun angle gets higher and higher, especially towards April and into May, the Bermuda high becomes stronger. So these storms are further west, and we get these southerly winds, and there's still some cold air left in the northern plains and over the continent, but this Bermuda high really picks up in amplitude, and you get these jet streams that come out of the Gulf, and they come all the way up into the Appalachians. And it turns out that a lot of our birds use these winds, and they have a tailwind, and they just ride these winds north. And it's a phenomena that is very common, and I've noticed this for many years. When I retire eventually, I would love to do more research on this. But here's an example of, this was May 1st, this is 10 years ago, but I could pick out any of the, any May, but this works. Here's an example of a really good low-level jet. So what we're looking at here is the wind direction. So the winds are coming from the south here across the Gulf of Mexico, and this is in meters per second. So to get that into miles an hour, you double it and add a few miles an hour. So this is about 45 to 50 mile an hour winds coming right across the Gulf of Mexico. So you can imagine like a wood thrush or, a warbler species taken off from the Yucatan Peninsula, and then he gets up, and this is at the very lower part of the atmosphere, I should say that. We're talking maybe between 1 and 3,000 feet above ground level. And that's about where our passerines migrate. So these birds, they can get a tailwind. They're very small, and they go up in height, get to this low level jet stream, and I believe it transports them north with very minimal energy expenditure. And again, I would love to see more research done on this. And I'm not a biologist, so there could be some research projects that I'm unaware of. But this is at about 1 to 3,000 feet up. This is up to 5,000 feet up. Again, very strong south winds. We're running around 40 to 50 miles per hour up, right across the Gulf of Mexico into the, Mississippi, Alabama. There's some really, really good migration places down along the Gulf Coast that I know you folks are aware of. And then we get higher up, the jet stream actually shifts further west. So this is up at 10,000 feet. Most of our passerines, at least we don't believe, that migrate at night, do not go to that level, though I'm not 100% sure of all species. I know that swallows, believe it or not, migrate very high up. In fact, there is some evidence and research that now shows that swallows, and they migrate mostly in the day, will fly above the hawks, which makes sense. The passerines, a lot of like the vireos, warblers, tanagers, all the birds that we're anxiously awaiting, they fly at lower altitudes and they fly at night to avoid the predators, the hawks that migrate during the day. Okay, swallows migrate during the day primarily, and they migrate higher than the hawks. So that's something I've learned recently. So that's a low-level jet stream that is very common in the springtime, and I think that helps these birds get across the Gulf of Mexico. So, and another thing that's important when we look at this low-level jet stream, it's the atmosphere is what we call stable, and I'll explain what I mean by this. Warm air is lighter than colder air, so just follow along here. And as air moves up from the south, right, it's warmer down south, it's colder up north, right? So as you get winds aloft, so let's say the winds 2,000 feet above us are warm and they're coming from the south, warm air above cold air is stable because cold air is denser than warm air. So we get very stable airflow and it's laminar, it's very smooth. So if you're in an airplane and you're flying, like if you were flying today, it's going to be very smooth. There's no turbulence. And I do believe that songbirds in particular, little birds, hummingbirds, songbirds, they're going to fly in stable environments. So this low-level jet stream is really important for them, I think, because the atmosphere is stable. When the atmosphere is very turbulent, it's not going to be easy for a small songbird, especially to fly across the Gulf of Mexico or even over to land for that matter. So I already talked about this. I'll move on here. Another thing that I have noticed through the years is in the springtime, from the Appalachian Mountains and the points east, so this is like a schematic right here, cold air likes to lock in, unfortunately. That's why we tend to have springs don't come as quickly as we'd like them to around here. If you go west of the Appalachians, the warmer air tends to move north faster than east of the Appalachians. This is called what we call cold air damming. The cold air dams up east of the mountains. And we tend to see stronger low-level winds west of the Appalachian Mountains in the springtime. This is something that I have noticed year after year after year. And it's in the climatology. So what happens is, if you look at this map, you've got your Bermuda High, this cold front is moving east, and the winds are funneling west of the Appalachians. So what happens is you get this little squeeze. The colder air is coming in, the warmer air gets squeezed up against the Appalachian, between the front and the Appalachians, the colder or the warmer air gets squeezed. So you get stronger low level winds from like Louisiana, Mississippi, Alabama, up through the eastern Great Lakes. Then you get east of the Appalachians and you have colder air in place, and cold air just doesn't move. It's heavier and denser. It doesn't move as quickly. So we often see stronger low level jets west of the Appalachians up through Western New York and even into the Finger Lakes, believe it or not. And then you get to like Binghamton, Elmira, and south, we don't get the stronger low level winds at times. And I have noticed that birds will arrive in Ithaca and Buffalo and Rochester before they arrive here, and certainly even in the Poconos and areas like that. And one thing that really shows us well is, all right, I already went through this. So here's a good example. This is from eBird, and this is April. This is the all the April eBird reports over the past 10 years. And the more purple you see, the more reports. And notice how in this, like in the Carolinas and even all the way down in the Carolinas and in Virginia, just not that common. But you go further west and look at all the reports. And some of these birds are reaching all the way to Minnesota before they even reach New England. Minnesota is much further north than New England. So that's that effect. And I could go through species after, I just used the Tennessee. This is the Tennessee warbler. I probably didn't say that. This is one species, but I could go through species after species after species. And it's like this. The warmer air rapidly gets up into the plains and the Midwest and Ohio Valley before it gets to us. So if we look at the Tennessee warbler distribution in May, you'll notice it's still a centroid here, but notice how it's in the northeast, but not much in the southeast. Not much in the southeast. They just go right around the southeast. They're following those low-level winds. You can almost see they're coming across the Gulf, and they're following the low-level winds west of the Appalachians, and then eventually up over us, up into New England. And then, of course, they have another path that goes up in another part of Canada as well. And they almost entirely miss the Southeast United States in the springtime. So it's this just cooler air that just kind of wells up. And it's not really cold in the Carolinas, but they just don't get those low-level winds. I really think it's this low-level winds that's important. And I've seen radar displays, and I don't have any good examples to show you, but it'll be early May and sunrise hits, and you'll see all these bird echoes that persist in the Gulf of Mexico, on the radars in the Gulf of Mexico, like Alabama, all the way to Louisiana. There'll be these bird echoes, and the birds are still like 5,000 feet up, and they're still heading north. They're not stopping. They don't need, and the weather's fair down there, obviously. And we've heard that many times for birders on the Gulf Coast, that the weather's quiet. If it's sunny and warm, it's beach weather, birds just keep going. So you think a small songbird would have a lot of trouble crossing the Gulf of Mexico. Obviously they don't, because during like when they're having warm weather down there and there's no storms and the winds are out of the south, they just keep going. They don't stop. So obviously they have enough energy to make it not only across the Gulf, but to make it further inland, further north. So, it's kind of interesting. I would love to see research done on that. I know that they've done research with semi-palmated sandpipers, and they have shown that they use some kind of technology where I think when they're foraging, it's some kind of a I don't know the technology. They detect the birds when they're foraging because they're near water, and it sets off some kind of electricity or some kind of emits some signal, I should say. Doesn't shock the bird. And they found that the birds will come down from the Arctic where they breed and they stage at Hudson Bay. And then they literally make a nonstop flight to northern South America. And these are little semi-palmated sandpipers, which are about the same size as songbirds, really. I mean, they're very small birds. So to me, it's like, do some of our songbirds literally migrate, like a black-throated green warbler, just as an example? Do they literally migrate if the wind patterns are favorable? Do they migrate from Central America right to their breeding grounds up here in the Northeast, or at least in the Southern Appalachians where they do nest? I mean, is that possible? I don't have an answer for that, but I think that would be really interesting research. It's just they don't have, I don't think anybody has put satellite telemetry on those birds or anything. I don't know much about those technologies, but makes me wonder, because if a semi-palmated sandpiper, which is pretty small, can migrate from Hudson Bay down to northern South America in one straight shot, why would a songbird not be able to, migrate from Central America to the southern or central or even northern Appalachians? Just a question. I don't have an answer for that. And then we have fall migration, which I love fall migration too. I mean, migrations are just fun. So this is an example of fall migration. So at the very beginning, you can see there's precipitation that is heading off the East Coast. So the cold front has passed through. The winds are out of the northwest. As soon as the sun sets, the birds take off. And then the sun rises, they drop. So this is just a loop. This was from on October. So the general pattern is the cold front passes through, and then the high pressure builds in. And as that high is building in, we have northwest winds aloft, and the songbirds take off and they head in the opposite direction. And that's when the southeast United States tends to get most of its warblers, because you got northwest winds that go all the way down into the southeast. So so that's songbird migration. Then we let's change gears here, and again, that's nocturnal migration. So that's driven primarily by the winds. But then when we look at hawk migration, which I don't know if anybody's ever seen something like this before, it's incredible. I was up at Derby Hill one spring, quite a few years back. I need to get back up there. And the sky was just full of broad-winged hawks. It was just a spectacle that, I wish more people can see, because it's just amazing. I think even the non-birder would be impressed when they look up the sky and they see like a beehive of birds just spinning around and riding thermals. So the hawks use the thermals, broad-winged hawks in particular, and other species of hawks as well. Eagles and vultures to some degree. Bald eagles will use thermals. Golden eagles, we'll talk a little more about golden eagles. They're a little bit different. I'm sure they do use thermals in some parts of their range. And on the east, we'll talk about that a little bit. But these thermals are a way that these birds can, they can expend the least amount of energy and move long distances, and that's the goal of migration. I mean, the songbirds are using the winds, the hawks are using the thermals. So what a thermal is an area of land heats up. There's differential heating, meaning some areas don't heat as much as others, and you get a spiral thermal. The air just spirals as it goes up, and then eventually you get to the top of the thermal, and you'll generally get clouds forming at the top of the thermal. Many people, you've seen those clouds, puffy cumulus clouds. That's a base, that's cloud base, that's the top of a thermal. And a lot of times the hawks will spiral up, they reach the top of the thermal, and then they glide off the thermal, and then they catch the next thermal, and then they glide up, or they spiral up the thermal, and then they glide down. And it's so cool to see that. You'll see the birds going up and up and up and up. And if you have a scope, you could just keep on them until they get and sometimes they'll get way the heck up there, and then you can see them, then they'll just glide right off of it. It is so cool. It is really a neat phenomena. And they'll just do this until they get to where they need to go. And there are some areas where the thermals, like around here with the mountains and everything, that really, really make it interesting. And then there's certain areas where these birds get bottlenecked like down in Mexico, and I think in Panama there's a good spot, and other areas where the birds really get concentrated, and they call it the River of Hawks. And it's an area that I want to eventually experience in my lifetime, where there's just literally, hundreds of thousands of hawks just moving, and vultures too as well. So, but let's talk about this a little bit. In the springtime, and this is something that, it's still cold out, but our sun angle, if you didn't notice, is getting high. In fact, we are only 3 or 4 days away from the vernal equinox, right? So our sun is about as strong as late September. And I'll tell you what, if you're outside all day long and the sun is out, which again, it's spring here, we don't see a lot of sunshine, but if it is a sunny day, I would recommend starting to put sunscreen on, because you can get burned, especially if you're sensitive, because we're getting to that time of year now. So the spring, especially as we get into April, the end of April, when the broadwing hawks come back, the thermals are going to be higher because the sun angle is similar to what it would be in August. By the end of April, a month after the vernal equinox, that's like August sun. It's a strong sun. So the thermals can get up to 7,000 feet, over a mile high, versus the fall. As you get from September to October, the thermals are going to be lower because the sun angle is lower. The higher the sun angle, the more heating, and the higher the thermals. So in the springtime, I find sometimes it is very hard to detect broadwing hawk migration, especially on a warm day. I'll catch some in the morning taking off, but by early afternoon, it's so hard to see them because they're way the heck up there. They're so high up. Whereas in the fall, they won't be quite as high because the sun angle is lower. So, however, we are very fortunate that we have Derby Hill and Braddock Bay. And for springtime, these are some of the best places. I talked about Derby Hill. I mean, that place is amazing. Why is that? And it's pretty simple. So think about this. If you have a southwest wind day, I can't wait till we have a day like this. Usually late April, you get that first really nice warm day where it's pushing 80 degrees. The sun is out. Oh my gosh, I can't believe that. Sun and 80 degrees and just beautiful weather. You get southwest winds, right? Generally, that transports that warmer air in, and you have all kinds of thermals on the land. The broadwing hawks are migrating north. They're taking these thermals and they're riding them and heading north. Then they hit the lake. There's no thermals over the lake because water is cold. Okay, the heat capacity of water is very high, so it takes a long time for the lake to heat up. So it's very cold right now. The thermals collapse along the shoreline or just off the shoreline. So imagine a bird at 6,000 feet is riding thermals and then gets towards the lake shore, and all of a sudden the thermals collapse. There is no thermals, and they'll drop and drop and drop and drop, and they congregate at very low altitudes. And at Derby Hill, for instance, it's right here. So the birds will often drop and then they go around the lake. They will not fly over the lake because there is no thermals. Braddock Bay is over on this area here. So the birds will then literally migrate along the edge of the shore and they'll go around the lake. They will not go over the lake. So you get these bottlenecks in these areas. And we're fortunate because it's not that far away. It really isn't. And, if you get a good day, southwest winds, especially during the broadwing hawk peak in late April, if you get a chance, I recommend going up to Derby Hill. It's maybe an hour and 45, 2 hours, just straight up 81. But the weather has to be right. If the weather is not right, you won't see much. You won't see much. But anyway, and these thermals collapse over the lake, and it's an amazing phenomenon. We're very fortunate. We're close to that. And then, of course, in the fall, I mean, obviously northwest winds, and we have the Appalachian. Of course, this is just a very crude schematic, but we have the Appalachian Mountains. We get northwest winds. The birds, you know, fly right down the mountains, and they use the thermals. But remember, the thermals are weakening in the fall because the sun angle is going down. So they're also using the uplift of the mountains with the northwest winds, as I crudely show in this diagram here. The winds come out of the northwest, and there's an uplift over the mountains, and there's thermal activity as well. So you have the combination of both, because especially as September goes towards October, you're really losing the thermals. The thermal heights are getting really low, so the birds are relying on the winds more. And then by the time you get into November, which is starting, is the peak for golden eagle migration, thermals are almost non-existent. So they're really using the winds, the strong winds over the mountains. So, and I believe, and golden eagles migrate early. Like in fact, we've had a very good spring for golden eagles this year. I've already seen 3. Last year I had 0. I just didn't get lucky enough to get one. I've had 3 so far in the last week actually. So, they migrate early enough that the thermal activity is quite weak right now. It's starting to pick up a little bit, but they are very high up. Golden eagles are very high up, so they're just using the winds. They're using the winds. I've had bald eagles pass over my house. I live on a hill. I'm fortunate I have a nice view, and I can watch hawk migration literally from my house. And I've seen bald eagles ride thermals, but I have yet to see, and again, I'm sure that they do, but my experiences with golden eagles are, I just know it's a golden eagle when I look, and it's so high up. So they're just taking the winds. So any questions? And I'm going to go into some vagrancy now. So I tried to just cover a few things on migration from songbirds to raptors. I mean, obviously there's many other different types of species of birds, but just the ones that we notice the most. Any questions at this point before I move on? Yes.
Yes, thank you, Dave. So for golden eagles, you say they're high up. How high up roughly are you talking about during the fall migration?
I have to say most of it really depends on the winds. I would say it depends. I've seen them generally about a mile up. I'm estimating about a mile up. However, I have seen situations where if the winds are really blowing very, very strong, the raptors, like the red-tailed hawks, migrate about the same time the golden eagles. I've seen the red-tailed hawks will be down at almost mountain level, whereas the golden eagles will be just above the mountains. So I've seen that too, but the winds were going like 40, 50 miles an hour on, I used to watch hawks down in near State College, Pennsylvania, at this one fire tower. And the fire tower was like 100 feet above the ridge line. So you had a really good view. And I saw some golden eagles pass at eye level, and I was looking down at the red-tailed hawks. So, but that was a very strong wind day. When, what I mean by that was the winds were very strong down near the Earth's surface. So I really think it's variable depending on the wind, what altitude. I think the stronger the winds are, the lower altitude that the birds are going to migrate. That's just my experience. But golden eagles are pretty good. I mean, they could fly. I mean, they do fly at different altitudes. And I've seen golden eagles actually come down, and they'll actually go down into the valleys, and they maybe if they're hunting or whatever, and then they'll come back up. So I don't know. It's variable with them, but most of the time, in my experience, they're pretty darn high up. So,
Dave,
yes.
Number of years ago, maybe 15 or 20, there was an event at Showcup Field in Ithaca where there was a huge dropout of migrants. And I think that happens, and it might be called dropout. I don't know. What do you know anything about that?
Yeah, so something like that would be, and I was going to talk about this in a little bit, but we can talk about it right now. What happens in the fall sometimes is you get a cold front will pass through late in the day, so the sun is still up, and colder air just seeps in, and the winds are favorable, and the birds all take off, and then fog forms. And then when fog forms, anything that illuminates fog is going to attract the birds down. So that is what happened in that field, the Shokop field in Ithaca. And I've seen that around here too. I have there's a church over here that they have these big spotlights on all night long. And when I have fog here, oh my gosh, it's so bright and the birds are just everywhere. So birds are attracted to illuminated, anything illuminated. And I think if there's fog that's lit up, the birds come in. So that's what happened at Shokop Field. So when you get these cold fronts that come through, in all honesty, they don't have a lot of wind with them. The cold air just kind of oozes in. There's enough wind that the birds will take off. They don't have a headwind. The winds are maybe 5-10 miles an hour. So the air mass just kind of seeps in and it cools, and there's still enough warm air just aloft that you get a little bit we call mixing, and you fog in, especially on the hills. And those are the nights really that are most dangerous for our songbird migration. That's when they're going to collide with buildings, lit buildings, communication towers. That's when we tend to see the most mortality, is those type of nights. If you get a strong cold front come through and the cloud base is 4,000 or 5,000 feet up, generally speaking, I don't believe we see the mortality at these the communication towers and other obstructions that unfortunately affect our nighttime migrants. So that's just my experience. And I've noticed it in the fall, not as much in the springtime. It's mostly a fall phenomena. Okay. All right. Well, let's talk a little bit about some vagrancy. Okay. So we've got this was a very interesting event. Hurricane Sandy again, this goes back to 2012, but it still is an amazing event that occurred. And first of all, the storm had an unprecedented track where the storm, literally came up the coast and then backed in on us, tracked in, across New Jersey into, into southern Pennsylvania, and then it came up through us, which is just unprecedented. And it occurred the end of October. And what was very interesting, after this storm, birds like magnolia warbler, indigo bunting, and bay-breasted warbler showed up again in southern New England and in the Northeast United States. And they had been gone for a while, especially indigo bunting. I mean, here it is early November, and there's still magnolia warblers reappearing in southern New England and New York State. And you can look at eBird, it's amazing. So working with one of the ornithologists, Andy Farnsworth at the Cornell Lab of Ornithology, we ran this is a trajectory model that basically takes the airflow and brings it out in time. So most of those birds, prior to when Sandy was hitting so we started the trajectory on the 27th of October, right before, when Sandy was down here. And this is where, indigo buntings, magnolia warblers, bay-breasted warblers, and other species too. These are just a handful. This is just a sample. Most of them were down here, and the trajectory from this storm literally went like this. So that by the end of October would bring them back up into the Northeast. So what happened was these birds, this is what we think, migrated normally to where, they were heading towards their wintering grounds. Sandy hit and brought them back north. They got caught in Sandy circulation and they were transported back north, and then they had to migrate south again. So, one wonders how, when we have these hurricanes, these big storms, how many birds really do perish? Because think about that. The poor things, they migrate to the tropics, and next thing you know, they find themselves back up in New England again, and it's November now, So now they gotta go back. And do they have the energy requirements to make it? I mean, I don't know. Hopefully, but this was a phenomena that was very well known. I mean, they were just showing up everywhere, and they had been gone. So that was one example of vagrancy, and we could run these trajectories. And this was one really neat thing with, I mean, unfortunately, I don't know how well the birds did, but it was an interesting phenomenon. And the other one that was very interesting was the northern lapwings that were appearing in the Northeast United States. And I actually got to see a northern lapwing. It's a life bird for me. There was over a dozen reports on eBird, and this occurred about the time that Sandy occurred. What happened was we had a blocking high pressure system up over Greenland. So we had this big high that was sitting over Greenland. Okay. It stayed there for about 2 weeks. That is why Sandy came north. It couldn't go up into the North Atlantic because, remember, clockwise flow around high pressure systems. It encountered easterly winds. So the storm came north and then it came in over us. Meanwhile, for 2 weeks straight, the winds are blowing east across the Atlantic into the Northeast United States. And we ran trajectories from where the lapwings were supposed to be, and they all ended up in the Northeast. So these birds were starting to migrate, and they hit these east winds, and they just, we only had, I think there was like about a dozen or so reports of them. So, I mean, the majority of the population obviously made it south, but probably a lot of younger birds or inexperienced birds, they ended up coming across the Atlantic. And it was related to this blocking high pressure that sat over Greenland for about 2 weeks. So you had a flow for 2 weeks that, and it was as far as I know, it was the only vagrant from Europe that we had. And it had to do with the fact of their migration timing. So a lot of these, and again, these are just a few examples. There's a lot more that I think can be done in this area of research, of looking at, weather patterns and patterns of vagrancy, and try to predict that, hey, man, we might be seeing some birds from Europe over the next couple of weeks. Keep your eyes peeled. Or if we get a very strong southwest wind that's unusually strong, maybe we can start looking for birds from the southwest or south central U.S. So that's some areas of research I would love to be able to dive into at some point in my life. So, but one thing I want to plug here is Birdcast. Birdcast, and I have it on a website. I preloaded it. Birdcast gives you real-time migration. So here it is, the night of March 16th. And this is as of 8 p.m. Eastern time. And it's using radar data from the National Weather Service. So it's something I worked with these folks, gosh, almost 10 years ago to launch this. And, they have done it was very archaic back when we did it, when I was helping them. And they really have, it's just incredible what they're doing. So you can see where the birds are migrating right now. And this is where the precipitation is. So this is where you might expect fallouts of birds. So certainly, in the Carolinas and Texas, could be a good day tomorrow to go birding. And that's right now. And then the forecast for tomorrow, this is based on wind forecasts. So we're going to see some more migration tomorrow. And then, tomorrow, the next day, so that would be the 18th. And we might see some precipitation, but most of the migration is still south of us. So I highly recommend this site. This shows the migration traffic. And there's a lot of cool stuff here. So I recommend you look at this site if you're interested in bird migration. So it's Birdcast. So now I'm going to go back. I'm going to go back to my PowerPoint. See if I can get this right. All right, so you should be able to see my PowerPoint, correct? All right. Climate change and birds. Let's talk a little about that. All these 4 species, 100 or so years ago, would be a rare sight in New York State. It's hard to imagine the northern, well, it's called the northern cardinal, but it really is a southern bird. It's a bird of southern affinities. And I have this old bird book from the 19th, before Peterson. I can't even remember the name of it, but it talks about the cardinal's range getting into like southern Pennsylvania, southern New Jersey. It's incredible. You know, same thing for the tufted titmouse, Carolina wren, red-bellied woodpecker. These are all southern birds that extended, you know, north maybe into Jersey, southern PA, but up here they were unheard of. The first cardinal to be at the Lab of Ornithology was 1914. I believe it was either 1914 or 1918. It was in the 19 teens, and Arthur Allen got a photo of a cardinal next to an evening grosbeak, which was the first of its kind. So, so cardinals were very rare, and because the climate has warmed, all of these birds of southern affinities have really become very common. I mean, it's incredible how many cardinals I have at my feeder. This year has been a great year for cardinals. I've had up to 12, 13 cardinals at my feeder this year, best year I've ever had with them. And you know, titmice, you know, Carolina wrens, they're all over the place. So you know, 100 years ago that wasn't the case. And if you look at the average temperature in the United States, so this is just the United States, not the globe, but you could see temperatures have warmed. You know, roughly, I don't know, 2 degrees Fahrenheit or so. You know, this is from the National Climatic Data Center, NOAA. And if you look at the winter temperatures, they've warmed about the same. So we've had, you know, again, there's a lot of variability in winter, but winters are getting warmer compared to 100 years ago. And, you know, cold winters, you know, keep the birds away. And I do think bird feeding, I think, has something to do with it. But I think it's a combination, really, of bird feeding and the climate change that is leading to these birds coming north. So, you know, we've warmed, we all know that. So let's look at, and again, I'm going to change on you again. I can go back and forth so much, but let's see. Okay. So I don't know if you've ever been onto the Audubon site, but it has really cool how climate change, and again, you could look at it for every state, and I just picked New York State just because we're in New York. And it has the species that are vulnerable to climate change and the ones that would be stable. And so I'll pick out a bird that I really like. I don't know why, I've always liked blue-headed vireos. They're the first vireo back in the springtime, another few weeks. So let's look at the current range of the blue-headed vireo. And this is in New York, but we could zoom out a little bit so we can get a bigger picture. So this is where they're at right now. So, you know, they primarily higher elevations. They, you know, range down the Appalachian Mountains, etc. So let's say we warm 2 Celsius. You can see that we will lose in New York State the blue-headed vireo significantly. All the red areas, that will be the range lost. And really, for New York State, it's a net loss. They would just be confined to the higher terrain of the Catskills and the Adirondacks, and we would pretty much lose them as a breeder in the lower elevation areas or outside of the peaks. And if you look at, you know, a lot of, you know, the areas where we see the gains would be further north. So they would range much further north with a 2-degree change. And, if we go 3 degrees, we lose it entirely at 3 degrees. So that's just one example of a species. The one that to be most concerned about, I hope this website works, would be Bicknell's thrush. Obviously Swainson's thrush, hermit thrushes would probably go north, but they don't have Bicknell's thrush. Ugh. They should have Bicknell's thrush on there. Bicknell's thrush, as many of you know, is endemic to the higher elevations of the Northeast United States. They nest in stunted spruce and fir woods, very close to just below tree line. And with warming, those habitats will disappear. And the birds, they're endemic to the mountains. And as those habitats disappear, they'll go extinct. So they're definitely in peril with climate change. Some of our other favorite birds like Swainson's thrush, hermit thrush, certainly those are northern birds. Any birds with northern affinities. A lot of our warblers, black-burnian, black-throated blue, black-throated green, those type of warblers, they're going to all be heading north because and you're having a talk on how the forests are changing, and that's part of the reason. The forest will change, and these birds would hopefully be able to move north. And, it's not like it used to be. Climate has definitely changed in the past. We've had ice ages. We've had rapid climate change in the past, but we didn't have, mankind that has, cut the landscape into pieces all over fragmented the landscape. So, with this climate change, how will these birds be able to find, be able to move with the changing climate like they did when we came out of the ice ages? Because these birds have been around for, a couple million, some millions, at least 2 or 3 million years they've evolved, and they've evolved with the ice age cycle. So they're used to climate change. However, they're not used to a rapid climate change like maybe today that we might be seeing. And they're not used to a fragmented landscape that we have. We didn't have that 10, 15,000 years ago when we came out of the ice age, and the climate was warming rapidly. So they were able to move north. So it's unknown how that will be. But I do recommend, go to this Audubon, and you can look at all different species. So now I will go back, and I will go to the new share. Sorry about this back and forth thing. So then we'll get to the last part of the talk, green energy and birds. So there is going to be a proliferation of solar farms. I think that's a pretty good bet, right? I'm not as up on a lot of this as you folks. Will this threaten our field birds? And the other question I have, are they taking forests down, or are they really focusing just on field, areas that are already just fields? And again, I worry about energy companies because, obviously just because they're a green energy company doesn't necessarily mean that every one of these companies is going to have the best interest of the environment. I think if we were to just assume that, we would be being naive. Now, there are some companies I totally agree that they would be good, but some would be just looking to make money. They got to make some money, but one of the things that I have seen, bird-friendly solar farms, and there is a study, and I have it here, that in the UK, that they actually found the biodiversity was actually better on some solar farms in Europe because they had native plants and grasses, and it was bird friendly. So this could be an opportunity to help our field birds if it is done properly. And again, we're talking about wind farms here. I'm sorry, we're talking about solar farms. Been a long day. So here's a great example, and I hope you folks have seen this. It's on Audubon, and these are all native pollinator-friendly pollinator plants to help our bees, which we know have had some issues. and birds too as well. So and Minnesota has adopted this in their at least it's in their legislature that they want, all of these solar farms they're really encouraging, incentivizing, native plants. So if you think about it, so if you have cornfields, which, they're not great for especially nesting birds, but let's say that gets converted to a solar farm and they leave just 1/3 of it with natural grasses, and they mow it maybe in August, wait till all the field birds nest, that could be a net positive for our birds. But I think we have to be an advocate for the birds, and I don't know. I hope that these solar farms take this approach, a bird-friendly approach. Does anybody know, like, I know there's that project in Owego, if they are looking at this approach, because it doesn't cost the companies anything. I mean, if that's just sod grass, it's going to have much less value to wildlife versus native plants. So is that something that you folks have been kind of in contact with? I don't like knowing what, talking to the developers and, trying this approach versus just sod.
Well, I saw a presentation recently that involved solar farms being designed in such a way that they might possibly be compatible with dairy operations and also sheep operations. In fact, in my my alma mater in Southwest Ohio, they have a solar farm that in which they are raising sheep.
Okay.
I have not had time to look into this specific solar farm that's being proposed for south of Owego, what their plans are in terms of whether they're going to use pollinator-friendly plants, wildflowers, anything like that, or it's being proposed for a farm owner. And I'm sorry, I'm busy with so many things. I can't know everything, but I know that somebody that wrote a letter advocating on behalf of that lives in Owego, specifically in the letter to the Board of Zoning Appeals for the town of Owego, said they recommended, in terms of this person that's a resident of Owego, recommended to make a pollinator friendly use of wildflowers, that type of thing, native plants. So people are aware of this. And also I know that Adam Flint, who has been helping to develop some solar farms, he is an advocate for this as well. And he is part of the network for, oh boy, I'm sorry, for
Network for Sustainable Tomorrow.
Network for Sustainable Tomorrow. They just changed their name like a month and a half ago, and I'm still stuck on Binghamton Regional Sustainability Coalition because that's what they used to be known as. So I always get tongue-tied trying to come up with a new name. But anyway, bottom line, what I'm trying to say is there are people that are aware of this, and many activists are advocating for this as well, but it's difficult to bring that forward because the bigger fight that we have is always the not in my backyard thing that we first have to get over. And that is so difficult that many projects just get killed outright. So we're so busy fighting those fights and also opposing fossil fuels at the same time, where they want to keep building pipelines and do more fracking in Pennsylvania and hauling of all kinds of stuff by rail and bomb trucks on our highways carrying Pennsylvania gas across our highways. That it's just difficult to do everything. And so anyway, long-winded answer, but sorry, I just don't know.
Yeah, I just brought it up because it could be an opportunity to help, help the environment some. I mean, obviously with the fossil fuels, I get that. But what I worry about is I worry about our field birds. I want to make sure they still have habitat, and a reasonable amount of solar panels would be fine. But if we start just converting so much agricultural land into solar panels and solar farms, and then we don't have good habitat, we're going to lose a lot more of our field birds, and that's something that I don't think any of us want to see. So again, it just something to just be aware of. I mean, it can be done in a way that is friendly to our birds and our pollinator, our bees. So
One thing I want to point out is I attended a presentation that was put on a few years ago in Owego by a retired engineer who went through the calculations for what it would take to power all of New York State by renewable energy and how much land area that would take. And if I remember correctly, I think the land area he was talking about with a combination of primarily wind and solar was somewhere between 2 and 3% of the land area. So I don't think that's unreasonable considering the scope of the problem with climate change if we don't address the problem and stop polluting the world with fossil fuels. And, the costs have come down, the technology has improved. So the solar panels are getting more efficient, wind turbines are getting more efficient, storage technology is getting better. So it's not like it can't be done because of technology, advocacy, and political willpower. And I agree with you, Dave, that we do need to do what we can in terms of preserving habitats, trying to make it as compatible as possible with this transition to renewable energy, and do the best job that we can. So thank you for bringing that up.
yeah, again, just bringing up that it could be an opportunity, and and it is being done in other areas. So, all right, so let's talk about a little bit about wind farms. Obviously, collisions are a concern. Obviously, our Raptors and the poorly sited ones and the older generation turbines. The older turbines from a couple decades ago were a big problem. Of course, at Altamont Pass, California, is our most infamous example that everybody goes back towards. And that obviously has done a lot of damage. But the newer turbines, from what I've read, they're not as they're easier for the birds to see versus the older ones. And most bird deaths still are songbirds colliding with these turbines during nocturnal migration. And Julian brought up the Shokoff field effect. Most of the collisions occur on foggy nights when the mountains or turbines would be obscured by fog and the birds are flying lower. And I would add to that generally when we have foggy nights like that, the wind is not blowing very much. There's not enough wind so the warmer air is still just above the surface and it mixes down and you get the fog. And the winds aren't really blowing. So I don't think the turbines really are going to be moving very quick. So that's not going to be the issue. It would be the birds just flying, being attracted to lighting, if there is lighting. So I know that in some of the turbines, what they'll do is they won't light up the facilities because there's obviously, buildings around there. They use motion sensor lights. And that saves them energy because, it actually saves them energy. So by not having those lights, they obviously have the aviation lights, for the FAA required lights, which is very similar to communication towers. So I think, for our songbirds at least, and I know the new towers, and we've had many new towers that have gone up. These are communication towers. So we kind of have both communication towers. Obviously the tall buildings have been around for, 100 years or so, probably 50 or 60, 70, 100, up to 100 years. We've added a lot of communication towers. The one thing that, and again, I've read about this and I don't know if any studies have been done. Supposedly, they've changed the lighting requirements to be red flashing, which what I've read supposedly, and this is from some research, reduces collisions by about 70%. And I believe the turbines have the same lighting pattern. It would just be a red flashing light. And if it's a red flashing light, supposedly the birds can reorient themselves and not, crash into to the, to the tower or so hopefully that would reduce some of the tower and wind turbine kill. During windy nights in the fall, especially strong wind nights when the wind turbines are really going to be moving, the songbirds likely aren't going to be moving. The winds are just going to be too strong for them. So I don't know exactly. I mean, I know that there has been some mortality, but it really, we're talking, I think they had a big mortality event. I was down in West Virginia, and it was several hundred birds, which, so one thing that I've done is I went through, we've seen a proliferation of communication towers. We know that. They've just sprung up like crazy. Every mountain you look at has a communication tower on it, and it has lighting on it. In the last 60 years, we've seen a lot of these suckers go up. So one of the things I've done is, and there's a really good website up in the Canadians do it. They do a banding site, and they do banding studies, and they correlate the number of catches with the number of man hours to get a migration index, so they can get an idea of what the bird populations are, at least during the migrations. So for instance, here's Long Point Observatory, which is up in Ontario. And I think some of the data prior to 1980 looks a little bit fishy, but I think from 1980 on, looks, there was a slight increase and pretty much steady. Red-eye vireos, in the spring, pretty steady. And actually, since the 1980s, they've actually gone up. They're actually increasing. And they're a bird that's very vulnerable to collisions. So obviously, it's not really impacting. It's not enough to impact their populations. So we add some more wind farms in, but really, are we going to add as many wind farms in as there are communication towers? I mean, you really think that is a reality? That every mountainside is going to have a wind turbine on it? I kind of don't think that's going to happen. But certainly communication towers are all over the place. And yet red-eye vireo seems to be doing pretty good. We look at our ovenbird, another very common migrant. The numbers are, again, I think the data is a little bit fishy back here, but from about 1980 on, pretty steady. But some lean years, but some good years too. But overall, a pretty steady spring and a pretty steady fall. This goes all the way to 2019, or 2018. So it's pretty recent. And in the last 60 years, or especially the last 20 or 30 years, we've seen towers go up all over the place. And yet it doesn't seem to be affecting the population of ovenbird. And I got one more, Blackburnian warbler, one of my favorite birds. Again, same thing for them. Just very little population change. Again, I would be cautioned about the data earlier. I don't know if there was really that much of an increase, but the data earlier than 1980 looks fishy. But really, certainly since the 80s on, it looks like pretty steady populations. And these, are well sampled, so they have a lot of captures. So this isn't, these are good statistics here. So, and again, that's just a cross section of some of our songbirds. Our field birds, we know, are not doing well, but that's because the habitat, we're losing the field habitat because the farms are being overgrown, have been converted to farms have been abandoned in the Northeast, and the habitat's changing. Plus, the farming practices have changed quite a bit too. They're these from what I've heard, with the pesticides and herbicides, and they're not, they're using up every square inch. They're not leaving, corridors where birds would be able to nest. So our field birds are showing declines, but that's been ongoing, and I don't think it's related to tower kills or anything like that. That's related to habitat and changing agricultural practices. I looked at mainly forest birds because they do collide with towers and wind farms, and they have at least a pretty stable habitat. So that's that. So let's look at wind farm and raptors. I think there is definitely more concern here, more vulnerable, especially the birds that soar. Golden eagles. I mean, I know that everybody's worried about the golden eagles, and that, the Altamont Pass in California, again, poorly sited. But there are new technologies. I know that they're in. I think the wind farm that's going up in Windsor, they're using some kind of artificial intelligence to shut the turbines down. I believe, is that true? I thought I read that somewhere, that they're gonna, they have some of the, and they look out for these raptors if they're coming by, and they'll shut the turbine down.
Well, I can answer that. Thanks you for bringing that up. It hasn't been decided, but me personally, as well as other members of our local Susquehanna group, are advocating, both in person and behind the scenes. We are trying to make sure that the best available technology is used. And I have made contacts behind the scenes, even with the company that's producing this technology,
Okay.
multiple times over the last year. And the company name is Identiflight. That appears to be the best technology there is out there at the moment.
Right. I've seen that.
Protect, soaring birds. And they're improving their technology all the time. And a study just came out recently proving that they can reduce eagle deaths. I think it was 84%, if I remember the number correctly.
That's awesome. And another thing that they've done in Europe, but the FAA won't allow it, or it's not approved by the FAA in our country, but they painted one blade black, which to a wind company, that would be pretty cheap, right? And they reduced collisions by 71%. It allowed the birds to actually see that there's an obstruction there that they need to stay away from. That's a really easy solution. I mean, my gosh, if that's all it takes, I don't think any wind company would have any problem. That's not going to cost them a fortune. It's not, they don't have to shut things down. Again, it's one study. It probably needs more study, but I hope, and these are the type of things I hope continue. And I know in Europe, they're doing a lot of studies on green energy and impact, and reducing environmental impacts. Hopefully some of that stuff will get over here to the United States. Because if that's all it is, this was just one study, but man, if we could just do something as simple as that, reduce collisions, wow, that's substantial. So let's take a look at the wind farms as, this is the current, and again, this is a density map of wind farms that are currently in place right now. And if you zoom in, you can see the individual farms, but you can see there's a lot of wind development in the Midwest because they got lots of winds, and we are seeing wind development here in the Northeast. So most of this has happened in the last 10 to 15 years. So let's take a look at golden and bald eagle numbers, migration index in New York State. We'll look at Franklin Mountain, and we'll look at Hawk Ridge. So you figure Hawk Ridge here in Minnesota, eagles that migrate south are going to wind up through this area and winter down here, the bald eagles especially, golden eagles too. And then here in the east, we'll use Franklin Mountain because our birds migrate down and they winter in these general areas. So let's take a look at the numbers. So, okay, yeah, all right, so I already showed that. So we look at golden eagle numbers. Golden eagles in the last 10 to 15 years has been steady, and there's been one really good year and one really bad year, but the general trend is either stationary or slightly up. This is from Franklin Mountain, and that goes to 2019. So even with the wind energy development that we've seen in the Northeast United States, the golden eagle numbers that are passing by Franklin Mountain really don't seem to be affected. In fact, if anything, they've gone up a little bit because they had a really good year in 2018, but 2019, again, it's variable, but statistically, there is maybe an increase at best, or at worst, there is no change, but at best, there might be an increase in the number of eagles that are passing Franklin Mountain. Okay. So that's good. Let's look at bald eagles. Bald eagles, big rebound, and then they've been pretty stationary, maybe a slight increase in the last 10 or 15 years as all this wind energy has popped up in the eastern United States. So at least looking at the actual data for this site, doesn't appear that there is any declines going on as we've developed some of this wind energy. Going out to the Midwest, though, where they've, like I showed you, I mean, there's a lot more wind energy that has developed in the Midwest. So that would be more concerning. And eventually we'll probably see a similar density here in the East, but they've really developed in the Midwest. So if we look at the populations now for Hawk Ridge, Minnesota, this is the golden eagle populations in the fall. They have done very well in the last 15 years. So, I mean, has there been collisions? Maybe. And again, we don't like to see any bird get hurt, but, you know, birds unfortunately get killed by many sources. But so far, bald eagle or golden eagle populations are doing very well at Hawk Ridge, which kind of, you know, is a good, you know, it's right in that area where there's all that wind energy development in the last 10 or 15 years, and it does not seem to be impacting their populations at all. And then we go to bald eagles. The populations are just soaring. They're continuing to increase. And, you know, they just continue to go up in these areas at this hawk migration site. And like I said, if I go back, all this wind energy has developed during that time period. And these eagles are coming down and they're wintering in this general area. And it just doesn't seem to be impacting their population. And then that, to me, again, we got to be careful. You know, I don't want to see wind turbines everywhere, but, you know, at least we're not seeing, the data isn't showing anything as of 2019 of any problems with our eagles yet. So that's good news. So, you know, and this is my summary slide. Green energy, it needs to be bird friendly. I mean, hopefully we can get solar farms can help provide some field habitat if it's done properly. We know that wind sighting is critical. New technologies, as was mentioned, can reduce impacts. And our data is still showing the nice increases that we've been enjoying for many years. I'm still a little concerned. I'll be honest with you. I mean, I'm a little concerned about this Windsor project. You know, I just don't want to see our eagles decline. And so far, things are going pretty good. And, you know, we can't sacrifice our bird populations as we transition to clean energy. And I think we all agree we need clean energy. You know, it's imperative that eventually, you know, we do switch over to green, you know, clean energy sources. But I think, you know, hopefully we can do it in a way that will not affect our bird populations negatively. We could help them. That would be, I think the solar farms can give us an opportunity to, you know, restore some bird habitat, you know, field habitat. So that's all I have. I'll take questions. I think I went a little bit long, but, you know, any questions?
Where did you get the data on the hawk observation? I mean, the eagle observation sites.
This was from Canada. Actually, I went to the Humana, the Hawk. Let's see, Hawk Migration Association of North America website. That's where I got this data from.
Thank you.
And yeah, it's yeah, just let me see, I could probably find it if you want. And they got all species. And some, you know, again, I looked at the eagles primarily because I think that's a bigger concern. And some of the other species, there's other things that are impacting their populations, like kestrels, you know. So some are declining, but I wouldn't necessarily attribute that to wind farms. You know, we know that golden eagles and bald eagles have just been on an upward trajectory, or at least stable. They've been doing very well since we've gotten rid of DDT in the environment, which was, you know, a huge environmental win. And these numbers are looking good, and that's actually, to me, encouraging when I see this, despite all the wind energy that's been developed in the central U.S. where these birds are migrating, and I'm still seeing the numbers are going up and up. To me, that's a good sign.
Why are birds, when they migrate, attracted to land in illuminated areas?
That's a good question. Julian, why are songbirds attracted to light? I know they are, but I don't know exactly why. I just know they are.
I know why supposedly insects are attracted to lights. They say, oh, the insects guide themselves by the moon. And so if they use a lamp as a moon, they end up going round and round until they end up in the middle. So, but that's always sounded a bit hokey to me, but I don't know about birds.
Yeah, I'm not sure either. They are attracted to light. So, and that it's, when they used to have just a non-flashing light on a tower, it illuminated, and especially when the clouds were very low, the light attracts the migrating birds in, and they would fly around, kind of like bugs fly around, like Julian said, bugs fly around a light. Birds would fly around the tower, and eventually they'd run into the guide wires, and then that would kill them. So by flashing the lights, they found that they're saving more birds. At least that's what they're saying. So the FAA now is requiring all new towers have to have flashing lights, and they say red flashing lights are better than the white ones. Again, I'm not involved in this type of research or anything, but that's the new standard, is to go to red flashing lights to minimize attracting migrating birds.
I have a question.
Sure.
You showed some interesting pictures of blue-headed vireos, how the range will change. Yes. And with temperature. But the problem for the birds is that their habitat is not going to move very much. I mean, it's plants, and plants simply don't disperse like birds can to new habitats. So right. I'm kind of wondering, I think that was the Audubon Society.
That was the Audubon. I just used that.
Yeah, but I was just wondering if they take into account that, or if they're just saying, oh, this is how the temperature is going to change, and that's what'll happen to the birds. But that seems simplistic if that's the case. Yeah,
and that study, that I have to look back at that study. So, but let's if we think about it though, and again, I didn't get into invasives at all, but our winters, are getting milder. We're not getting the minimum temperatures are not getting down to, where we used to have winters where we get down to 10, 20 below zero almost every winter. And that was enough to keep the hemlock woolly adelgid at bay, right? It's down to less than, I think it's minus 25 Celsius, minus 13 Fahrenheit. It's almost 100% mortality on the hemlock woolly adelgid, right? We're not getting that cold anymore. So the adelgids are moving north, and the hemlocks are dying, and blue-headed vireos and hemlocks go together.
Yep.
So, what happens is once we lose the hemlocks, that's related to invasive species and climate change. So there's both. I am not sure. Like we have northern hardwood forests, a lot of maple. If it gets too warm, will that stress the trees out enough where they would just start dying? And then other tree, you're right. It would take time for this to happen, because you're right. Plants don't just get up and move.
Right.
So, I just wonder if it'll lead to a degradation of the habitat, and maybe it could threaten the birds just won't be able to move in time. I don't know. It's a good question, because there was a time about 6,000 to 8,000 years ago, because of the Earth's orbit and orbital parameters and the tilt of the Earth, that our summers were actually warmer than they are today. And that had all to do with the Milankovitch orbital parameters and the ice age cycles. And Tannersville Bog, I don't know if you're familiar with that. They did the core samples, and they looked at the pollen samples. And back then, it's postulated that we had oak, hickory, and we didn't have northern hardwoods in the Poconos. Places now that are northern hardwoods were oak and hickory and sassafras, sweet gum, and trees that you would see in Virginia. And another study that showed the Adirondacks actually had more forests that were like the southern tier, and the spruce and fir was actually higher, was further north. And the birds were able to, but again, the climate change was over centuries, right? So the trees would have a chance then to slowly move north. So with the climate change today, and especially with the fragmentation of the habitats and everything, leads to other challenges as well. So yeah, that's a really good question, Julian. And I don't, that might have just been a more simplistic approach, because I agree. It makes you wonder how, yeah, like, I don't know. It just, yeah, it depends on how fast things warm up. That's the main thing.
Yep.
If it's a gradual warming, things, maybe it won't be so bad. I don't know. If it's a rapid warming, if it's 4 degrees, if we get like 4 degrees Celsius in 50 years, that's probably going to be a little bit too much, I think. If it's only 1 degree or 2 degrees, I don't know. It'll be interesting, but I don't think it's an experiment that we want to take. We have one planet, we got one planet, we don't want to do an experiment that could go very wrong. So, and we don't want. Go ahead.
Sorry, there's other things that birds rely on as well. That basically what I'm getting at is the emergence of insects, particular insects that birds need to live off of. And if they get cues to migrate at the wrong time, and the insects either aren't emerging yet, or maybe they do emerge because there was a warm up of maybe 3 weeks in a row, and then all of a sudden there's a cold snap that comes in with one of these Arctic outbreaks that we have because of the weakening and slowing of the serpentine eastward movement of the jet stream, that might kill off the insects. And now the birds are here. They migrated thinking that, hey, their insects are going to be ready for them to eat, and now they're dead and they don't have anything to eat. So there's other things besides plants that we have to worry about with climate change here. It's not just a steady warming, it's this what Catherine Hayhoe has referred to as climate weirding or weather weirding due to climate change. So, I mean, this is a complicated problem, and we've got all kinds of dangerous things that could happen that are hard to predict. We've got the Gulf Stream that's slowing, the Atlantic meridional overturning circulation that's slowing. So, I mean, boy, we really need to get this climate change slowed down and hopefully leveled off here. I know we can't do it in decades, but these few years that we have right now are our best remaining opportunity to basically, figuratively, change the direction of this Titanic that we have created with burning of fossil fuels mainly, and also poor agricultural practices as well that need to be remedied. So I started making a comment here, but I really want to thank you for your really detailed animated graphics, your explanation of how birds migrate and how they rely on wind currents that I wasn't even aware of at these lower altitudes. And I'm not trying to end this presentation now, so I'm going to stop talking. Other people can.
Well, we're in the question and comment period, so whenever people are done with questions, we're done. I mean, I'm finished.
I got one.
Sure, go ahead.
You referred several times to field species of birds.
Right.
Now, did they exist before this area became agricultural?
That's a good question. And I would, back in, before before the white man came over and, tore down all the forests, um, you know, I'm pretty sure probably not. I think it was, it's very possible that a lot of the field birds that we have today are because of that. And, with the return, with the abandonment of a lot of the smaller farms and the return of the forests, that's why our forest species, believe it or not, are actually doing pretty well in the Northeast. And our field birds are not doing so well. But then when you get to the Midwest and other parts of the country where the field birds were always in existence, it's the agriculture that is a threat to them out there. But in New York State, I mean, we've had these birds for, at least over a century or longer, probably from the 1800s on. I know Hensel sparrow's one that's getting very scarce. There are still a few grasshopper sparrows left. Vesper sparrows have gotten very scarce. I mean, they're still around, but they were common when I was a kid, and it's hard to find them anymore. Savannah sparrows, for some reason, I don't know why some birds do better than others, but Savannah sparrows seem to be doing all right. Bobolinks seem to be doing okay. If the habitat is there, they're there. Meadowlarks too, but as the habitat diminishes, the birds diminish with it. So
Okay.
yeah, I don't know what the right answer to that is, because you're right. Before the the European settlers came over, yeah, you probably didn't find those species in New York State. So, but I don't want to see them disappear. I like it. I like the variety. I think it's, I don't know. It's neat that we have them. I think we're lucky we have them, because you're right. In primeval times, I doubt they were here.
Okay, thank you.
May I make a quick comment about that?
Sure.
We used to live on Long Island, and in Nassau County and Long Island Western, near the city, there was a small patch when we used to go birding various places of the only grassland habitat, true grassland habitat left on Long Island, whereas apparently, as you were saying, before European settlers came over and messed things up, there were grassland habitats, Long Island and other parts east, and they were, those habitats were destroyed, along as you're saying, others. But yeah, field isn't exactly the same as grassland, but there have been certainly patches of, we'll call field and grassland the same for the moment. Just wanted to add that.
No, that's a good point. That is definitely a good point, because most of the fields we see today are fields because they're being cut. They're hay fields, and natural fields are likely kept that way because of fire. In the past, when fires used to be common, in dry conditions, especially when you get out to the plains, fires were part of the environment, and that would just keep the grasslands going. So
It would control the succession.
yes, and I think we're seeing the consequences of that. Suppressing burns, and then you add that with the warming and the drying that we're seeing in some parts of the world. California, Australia, the epic fires that they've been having it's just getting worse. It's just getting worse. It's just, you talk to the firefighters out there, and I know quite a few of them, because we provide weather support. The Weather Service does, to the fires, because weather fuels the fires. And they're saying they've never seen anything like this before. And these are people that have been fighting fires their whole lives, and they're getting these events that are just off the charts when it comes to fire out west. So it's a combination, I think, of, you know, the not allowing nature to spread fire and get rid of the brush. And then, you know, California has experienced some of its hottest years on record and driest years on record. So you add those two together, and boy, is that a bad combination. So, yeah. And it affects birds too. A lot of birds were killed. They found a lot of birds that were just dropping out of the sky in the Southwest this past fall from the fires. But they had those massive fires in California in the West, and there was a lot of birds that you know, they postulated left early, and they weren't ready to migrate, and they didn't make it. And there was a lot of dead birds found in the desert Southwest. So, yeah.
I could just add a couple short points. One is that the Native Americans actually did a fair amount of burning before Europeans came. And as I think a lot of people know now, there were a lot higher populations before Europeans came. And there is actually one iconic bird that was restricted to those kind of eastern habitats, which became extinct, and that was the heath hen, which used to range on those kind of grasslands in the east. So they must have existed.
That's a good point. I forgot about the heath hen, and that was a subspecies of the greater prairie chicken, or
I think so, yeah.
Yeah, it was a subspecies of one of those western. You're right. That's right, and they went extinct. You're right.
Yep.
That is true. Interesting. Very interesting. Yeah, I'm sure there were sections in the east that were grassland. Sure. So, yeah, interesting.
Some of it might have been because there were millions of bison that were across the plains as well, and that maintained the grasslands also, I'm sure.
Yes.
And the other thing too is just the ratio. There have been studies done, and it's hard to pinpoint the accuracy of these, but it's orders of magnitude in terms of the amount of birds being killed as a result of fossil fuels. They've estimated 14.5 million in the United States compared to 7 by fossil fuel fired power plants, and maybe by the pollution from fossil fuels as well. You know, they need refineries. There's open pits with polluted water in the fracking fields of Pennsylvania. And then there's only about 7,000 birds killed by wind turbines, and nuclear plants, even strangely enough, 300,000 per year.
Yeah.
So
yeah, I've seen that. Yeah.
Yeah, and it's like I said, it's hard to pinpoint how accurate these studies are, but when it's an order of magnitude different, at least you know it gives you some confidence that at least so far wind turbines are not as bad, and the data you provided tonight even adds to that, because it's a different way of looking at it when you're actually looking at the population trends of specific species that you would think would be vulnerable. And that gives me, you know, a better feeling about this, you know, that some of these reports I read earlier that I just told you about, you know, seem to be borne out by the trends in population of the species. So that's good news.
Yeah, I had no idea what I was going to find, you know, and I found this site, and you know, I started looking at all kinds of, and I was very happy to see, especially the one in the Midwest, because, you know, there's just been so much more wind development there, and yet the golden eagles are. I'm not seeing it. You know, the data speaks volumes to me. I mean, you could surmise, oh, this is going to be bad. This is going to be bad. But when you look at the data, it's like, well, wait a minute. The data is not supporting that. So that makes me feel pretty good. But I think, you know, we have to be cautious. I mean, with any energy company, as you know, even if they're green, you know, you got to keep an eye on them, you know, and that's what your club and others, Audubon and others are doing. You know, you got to be an advocate for the birds, and not just the birds, the ecosystems around them and everything. I mean, it's important. But the idea that fossil fuels kills more birds, I've seen that too. And yeah, I mean, I'd like to know like exactly how. And again, I'm not, is it because of the potential disruption of the climate? Are they taking that into account, or is it actually physically killing the birds? That's what I was wondering. Is that was my question on the when they talk about fossil fuels and killing birds.
This study was done a number of years ago, and I'm not talking decades ago. I'm talking a few years ago, maybe half a decade ago, something like that. And people have looked at it more than once.
Okay.
So they're not talking about projecting out into the future, what's going to happen 20 years from now or 50 years from now. They're talking about when they did the study.
Okay. Okay, that's good to know.
I'm not, again, I for the details.
Right. I'll have to. Well, I can look them up. But I just was curious about that. Like, were they factoring that in or not? And if they're not, like you were saying with the fracking and the pits and all that stuff and yeah. And again, and then you see the oil, the oil spills and the birds and the destruction of the, some of these ecosystems that have been just wiped out. You see the potential harm. And if we were, when fracking was proposed, and I was very worried about that. I mean, we all were. I mean, everybody was, that it was going to be a big issue, and it didn't happen up here. But we do have energy, more. We do have development coming. So, it just the idea here is that just want to make sure that it is friendly to our ecosystems and our environment. And I really think with the solar farms, it's an opportunity that maybe we could restore some grasslands. I think that would be outstanding. It could be a net positive. And in that study in Europe, they found it was a net positive for the bird diversity in the solar farms because they were using native plants. So it can be done. The solar farms especially can be done in a way that can be very, very helpful. It could be an actual opportunity to restore some habitat that has been lost. So
I have another question. Sorry, I'm taking up so much time.
well, it's fine. I mean,
but
very
this is something I thought of. One thing I thought of is have you, based on your experience and what you've looked at, do you know what might happen with the massive surge that we're going to get in the next 3 to 10 years of building offshore wind? And these are going to be large,
right.
Tens of dozens of square miles.
Right.
They're going to be spaced apart roughly 3/4 to 1 nautical mile apart, each turbine roughly. And I'm just wondering, do you know much about, is that going to affect migration patterns, seabirds, that type of thing?
Yeah, I've actually looked into that, believe it or not. And for our songbirds, they generally, it shouldn't be an issue for the songbirds. They try to stay close to the coast. Some birds go over the ocean, but generally they're high enough up. They don't want to be down near the ocean. For seabirds, at least the initial studies, and I know the UK and other parts of Europe have done a lot of studies on this. They found the birds tend to avoid the turbines. Like 99% of the birds are going around the turbines, so they're not colliding with them. And again, there's been a few studies that are showing that they're able to see the turbine and get out of the way. I think with hawks it's different because they're hunting, so they're looking down, and eagles, same thing, and they get caught off guard. Where the seabirds, they're just the way that their flight patterns are and everything. They were showing gannets and other really common seabirds that were not. The one thing that it might do is it might, depending on where they put them, it might affect some of their feeding areas, so that they have to be they got to, again, it's the sighting. I mean, they got to site them in places if it's a known estuary or something, an area where that's rich in fish and a lot of seabirds that utilize that for feeding, maybe that's not a good spot for it. But as far as the collisions go, it was actually pretty good. The results were pretty good. And another thing on the same lines with the wind farms in the Midwest that was actually good is they were looking at the American golden plover, which is a bird that is near threatened. They have the Arctic breeding grounds, and then they winter in southern South America, so they have a long journey, and they migrate through the plains primarily, and they use fields to forage. They farmers' fields in the springtime, and they found that the turbines they found no mortality in a 3-year study, and these were ornithologists. They weren't wind people, they were ornithologists, and they were studying the staging areas. There's literally thousands of these birds are on these fields, and they didn't record any collisions, and the birds don't seem to be phased by the wind turbines being there. That was the result of this one study. It's just one study. So that was kind of encouraging to see that, because, I worry about and we have a lot of shorebirds that migrate up through the plains, and they use those same fields, but I guess they're just able to avoid running into the turbine. I mean, birds have pretty good eyes, so they're able to avoid that, and it's not displacing them out of habitat, according to this one study. So that could be good as well. Again, it's something new, and there's concern because it's new, but these initial studies that was optimistic. And the same thing for waterfowl, that they didn't see any issues with waterfowl either, because of the prairie potholes in those areas. That there hasn't been any, at least they know of, any significant issues with collisions. So those are the initial things that I've read, because I've read quite a bit about this, because I'm an advocate for our birds, and anything new coming along, I get concerned about and just want to see. And I've done quite a bit of reading, and so far, cautiously optimistic. But again, I think if we saturate the landscapes with them too much, it could be an issue, just like any other development. But if it's done in a reasonable way, I don't think it would be. And you talk about battery storage. If we can just get that, as you said, that technology better, and it improves, that'll be very helpful too as well. So, and again, a lot of these are just my opinions and things that I've read. So I encourage folks to, educate yourself on it. There's a lot of resources on the internet, and read about it. And, but I think the main thing is let's get these solar farms to have pollinator friendly plants and grasses. I think that would be really outstanding. And it doesn't cost the companies really anything. It's just an awareness, I think. So I think that's the one thing we could do. That's pretty low hanging fruit, in my opinion.
Does anybody else have any thoughts or questions, or?
Yeah, I just want to thank David bringing the attention on the solar farms with the perennial gardens or plants. We do have a perennial garden, the Sierra Club, at the Confluence Park. If you ever by there, check it out. It has nothing to do with the solar farm, but solar farms are great places for them too. So thanks for bringing that up, David.
Yeah, no problem. Okay.
And thank you from my wife and I. We really appreciate this talk that you gave. It's really informative, and there's a lot more information than I was even imagining. So that really sincerely thank you. And please let's keep our communication lines open. If you hear of something, or see something that you want to let us know about in terms of advocacy related to renewable energy, or anything else related to bird habitat or the environment in general, please just let us know.
Okay,
because,
absolutely. Yeah.
I'm retired, so I try to do what I can, but sometimes I feel like I'm one of just a handful of people that are paying attention and trying to educate people. So anything that you can do to clue me and others in on our, in our Susquehanna group, especially on the executive committee. We're a small group of volunteers that try to do what we can, but it's not easy when we have so many battles to fight and so much information to keep track of. Plus, we need to keep our own group going. So it's not, and plus we've got lives to live too. We've got families of our own, and there's only so much time that we can do to do what we can. And we do have advocacy going on too. So we can feed information. If you find some new information that should alter the course of legislation, we've got people in Albany that are advocating on our behalf, in the Sierra Club. So, and we tend to have a once a week phone call with them. So we can feed information that might end up being able to influence legislation. So, please bear that in mind too, that we are trying to do what we can to navigate uncharted waters here to avoid the worst. And that's the problem with climate change, is it's unknown how bad it can get. But the more I read about it, the more scary it is. And if we flip too many self-reinforcing feedback loops, we will have a horrific mass extinction event, and humanity may also, at least civilization will break down, and whether people survive or not is an open question. So, it's serious matter. And thank you very much. I appreciate it.
Yep, no problem. Yeah, and I could share this presentation with, was it Jim Taft, is it?
Jim Taft is he's our delegate to the Atlantic chapter, which is the next level up, that basically represents Sierra Club at the state level of New York State. So he's the one.
Or I could share this with Victor Lamoureux, and have him send it to all you guys. So you'll have the web addresses.
Oh, fantastic!
And what I'll do is I'll throw the web addresses for these charts as well, because there was a question on that.
Very good.
Where you can get this data. So I'll throw that on there. So you guys will have all that, and then you'll have the information on the let's see, this whole thing about the good habitat. And again, it's just all
David, we recorded it, so we will have all the charts that you shared.
Okay.
And we'll put it on our website.
Okay. All right.
Yeah,
awesome.
so I think we're good with that. Thanks.
Okay.
So
all right.
Linked sources would be helpful if they're not in the presentation though. So if you,
I mean, if I share this with you, I'll share it as a PDF file, and you could just click right on that and it goes right to the source. And then you'll have the web address. So if you guys are, when you have your meetings, you talk to folks in Albany, you could reference some of this material. And, I think that's great. I mean, if you could get folks looking at this type of stuff, and advocating for it. And again, the solar companies, it doesn't cost them anything. That's the beauty of it. It's, it's cheap. And
sure. So yeah, Jim Taft would be an excellent person to send that to, and he'll share it with the rest of us, because I know you already have. Yeah, but he's not in. I don't know if he's in the Sierra Club, but I know Jim Taft is definitely. He's on the executive committee of the Sierra Club, so that's the most direct way to get it to us, and he'll share it with the rest of us. And thank you again. I really appreciate your talk. It was really fantastic.
Thanks for having me, and I hope to see some of you out birding. Okay. Thanks.
Okay.
All right.
Great birding coming up. Good to know.
Yeah.
Forward to it.
Thanks, Dave.
Okay, I'm gonna drop off. Take care.
All right. Take care.